Yeah.
All right. So what is a Pythagoras theory? Sorry, what is trigonometry? Trigonometry is basically for the triangle. So, but keep in your mind, either we are discussing the trigonometry or we are discussing what is the other thing? Mm, Pythagoras. Both are for a right angle triangle. We should have a right angle triangle. For example, if there is a triangle like this, and this is one more side of the triangle, and this is another side of a triangle. All right. So basically, for example, this is C, because that is a hypotenuse. So I am saying it's C. Okay. So there are three sides of a triangle, and everyone knows that this is a 90-degree angle. This is a 90-degree angle. Okay. So what we have to check here is sometimes we have to find the side of the triangle. Any side of triangle could be unknown. For example, if A side is given and B side is given and C side is unknown, then we can go for the Pythagoras theorem. We don't have to waste our time on the trigonometry. You can move toward the Pythagoras theorem. But sometimes, I mean, it happens sometimes that C is unknown, either B is given or A is also unknown. I mean, if two sides are given and one side is unknown, then you can move toward the Pythagoras theorem. But if two sides are unknown, but angle should be given. If the angle is given and two sides are unknown, if angle is given and two sides of the triangle are unknown, then you can move toward the trigonometry. Or sometimes the sides are given, but angle is unknown. I mean, this angle is known, which is 90-degree angle. This is a 90-degree angle. This is known, but the other angle is unknown. We don't know about the other angle. So if they're asking about this angle, so definitely we have to go for the trigonometry. So we have different rules. Let me tell you about the triangle in detail, so that we could start the topic. For example, this is one side of the triangle. This is another side of the triangle, and this is another side of the triangle. Okay. You can mark the 90-degree angle, which is this is 90-degree angle. Okay. Opposite to 90-degree angle, there is hypotenuse. What is hypotenuse? This is a side which is opposite to the 90-degree angle, but there is one more thing about the hypotenuse. Hypotenuse is the longest side of the triangle. Hypotenuse is the longest side of the triangle. Keep in your mind that hypotenuse will be the longest side of the triangle. Even you are working with the Pythagoras theorem or you are working with the trigonometry, you should know this point that hypotenuse will be the longest side of the triangle. Okay. What about two other side? If we are using a Pythagoras theorem, so we don't have to discuss the other side. And we can say any side as A, we can call any side a B. But if we have to use trigonometric ratios, so we have to check the sides of the triangle. Now we have, for the trigonometry, I told you the angle will be given. For example, this angle is marked or given or discussed. Now, so one is hypotenuse, that is confirmed that the opposite of the triangle is hypotenuse. What about other side? So let me tell you, this is the angle opposite to the angle, like opposite to the 90-degree angle, we have hypotenuse. Definitely, there will not be any other 90-degree angle in the triangle. The sum of all the angle of triangle is 180. If there is one 90-degree angle, so there will not be any other 90-degree angle. So other angle will be smaller than 90. So opposite to the 90-degree angle, we have hypotenuse. And opposite to other angle, we have a side which is called opposite. I mean, the name of the side is opposite. This is a side which is called opposite. And the side which is connected with that angle. Now we don't have to discuss the 90-degree angle. I mean, first we have to check where is 90-degree angle so that we could mark the hypotenuse. Then we have to forget about the 90-degree angle. Now we have to focus this angle, the black angle, means the angle which is smaller than 90. So opposite to this angle, there is a side which is called opposite. The name of the side is opposite. Hypotenuse is already marked. The remaining side is called adjacent, or you can say the side which is connected with the angle, that is called adjacent. This is adjacent. This is opposite, and this is the hypotenuse. So what is hypotenuse? Opposite to the 90-degree angle, the side, the longest side is called the hypotenuse. Then you have to check if there is any angle marked or given in the triangle. So the side which is connected, the side of the triangle which is connected with your angle, that is adjacent, and the side which is opposite to the angle, that is called opposite. For example, this is a triangle. This is your triangle. Okay. So for example, this is 90-degree angle. For example, I have marked this one. If this triangle is given, so you can see 90-degree, opposite to the 90-degree, we have hypotenuse. The side which is opposite to the angle, that is called opposite. And the side which is connected with the angle, the side which is connected with the angle, that is called adjacent. See, that is adjacent. All right, but there is a possibility. I mean, in your past paper, there are some complex questions. Sometimes two types of angle could be given. For example, this angle is also given. If you are working on this angle, if you are working on this blue angle, now hypotenuse will remain same because hypotenuse is the side which is the longest and opposite to the 90-degree angle. Hypotenuse will remain same, but now for this blue angle, this side is adjacent. This side is adjacent. This is not opposite for this blue angle. And the opposite side will be opposite. I mean, this side, which was adjacent for this black angle, it is behaving as opposite side for this blue angle because now this is opposite to this blue angle. So these type of questions could be given in your past paper. Let's solve. Wait, let me tell you about trigonometric ratios also. So we have sine theta, we have cos theta, and we have tan theta. These trigonometric ratios can help you to find angle other than 90-degree, or they can help you to find side sometime, the side of the triangle. You can find the hypotenuse, you can find the adjacent, you can find the length of opposite. Sometimes we can use these trigonometric ratios to find angle. It depends. But keep in your mind, whenever they ask you to find angle inside the triangle, definitely you have to go for trigonometric ratios. But for example, if they are asking you about the length of hypotenuse or the length of any side of the triangle, so first you have to check that can you use a Pythagoras theorem. If the Pythagoras theorem is applicable, you have to go with the Pythagoras theorem. If we are unable to use Pythagoras theorem, means two sides are unavailable, means two sides are unknown, definitely we cannot apply Pythagoras theorem in that case. Then we have to go for trigonometric ratios. Sine theta, cos theta, and the tan theta. What is sine theta? What is cos theta? What is tan theta? I mean, there is a formula. For sine theta, we have, let me change the color. Yes. Sine theta, the formula of the sine theta. Actually, we have to take a ratio between different sides. So let me tell you about sine theta first. Opposite divided by hypotenuse. This is the sine theta. Sine theta is equals to opposite divided by hypotenuse. Opposite, the length of the opposite divided by the length of hypotenuse. I mean, if hypotenuse is not given, the opposite is given. So you have to check that if the angle is given, then you can use this formula. I'll tell you that how to use formula. Let me tell you formula first. Opposite over hypotenuse. The other one is cos theta. Cos theta is equals to, this is opposite. So cos theta is adjacent divided by hypotenuse. This is the formula of cos theta. The formula of tan theta, tan theta is equals to opposite divided by adjacent. These are the formula for these trigonometric ratios, or these are called trigonometric ratios. For example, let me show you how to use these formula. Yes. For example, if I say, for example, if I said this side is 4 centimeter, this side is 6 centimeter, I want to know the value of angle. You cannot use Pythagoras here. Pythagoras, in Pythagoras, there is nothing like angle discussion. In Pythagoras, we have hypotenuse and other two sides of the triangle. We have to square them. Sometimes we have to take under root or something, but there is no angle discussion in Pythagoras theorem. So if I ask you to find angle, for example, there is a question on the screen. If I ask you to solve this angle, how can you solve this angle? Which formula you are going to choose here? You can say this 4 centimeter. Okay, the 6 centimeter line is actually the hypotenuse. All right. Then 4 centimeter. They are asking about this angle. For this angle, the line which is this is opposite for this angle, which is not given. But this is adjacent. Adjacent is that line which is connected with the angle. This is adjacent. So adjacent and the hypotenuse both are given. So you can see we can use cos theta. We can put the value of adjacent and the hypotenuse in this formula, and then we can rearrange the formula and we can find the theta here. Theta is the angle. We can find angle by using the formula of the cos theta. For example, let me show you some more examples. Yes. For example, this is the triangle. Let's change it. Okay. For example, this angle is given, which is 45 degree. For example, this angle is given, which is 45 degree. And this is given 6 centimeter. And this is given like 8 centimeter. Then what we have to find? For example, they are asking you to find this side. This is not necessary that everything which is given in the question that will be used in a solution. Some things could be given unnecessary just to make you confused. Let's see, I have a question mark here. This side is unknown. This side is unknown. First, you have to check the side which is connected to the angle that is adjacent. Okay, this is adjacent, which is unknown. The side which is opposite to the angle, that is called opposite, and the side which is opposite to the 90-degree angle, that is called hypotenuse. The triangle should be right angle triangle. If the triangle is not triangle, there will not be any hypotenuse. Hypotenuse is the side which is opposite to the 90-degree angle. So the triangle should be a right angle triangle. All right. So which formula you can pick here? We have to find adjacent. Angle is given. Okay, angle is given. Angle is there in all the formula. Sine theta, cos theta, tan theta. Theta is given. Theta is the angle. Angle is given. Which formula we can pick here? You have two options. You have to find adjacent. So you can see two adjacent can be seen in two formula. Wait. Yes, adjacent can be seen in two formula. The cos theta and the tan theta. Can you use cos theta? Let me check. Adjacent over hypotenuse. Yes, hypotenuse is given. Theta is given. You can find adjacent. What you have to do? You just have to do like this. You have to rearrange the formula. Cos theta. Hypotenuse is dividing there at the right side. When you shift hypotenuse there at the left side, it will multiply. Hypotenuse is equals to adjacent. You can put everything into the calculator. How you have to put the values. Cos theta. So you have to write cos in the calculator. What is theta? Theta is the angle 45. Multiply by hypotenuse. What is hypotenuse? 8. You can put this whole stuff in your calculator. You will get the answer for the adjacent. You can easily find adjacent with this formula. Or you have one more option. You can use the formula of tan theta. Tan theta is opposite over adjacent. How to rearrange the formula? Tan theta is equals to opposite over adjacent. So how you are going to rearrange the formula? Let me show you. We have to find adjacent. So see, this is tan theta. Adjacent is dividing here, so you can shift it here, it will multiply. Tan theta multiplied by adjacent is equals to opposite. We have to find adjacent, so we have to make adjacent a subject. Adjacent should be alone here. So this is multiplying here. You can shift it toward the right side. It will multiply. So see, this is adjacent is equals to opposite. Opposite is already given, na? Means 6 centimeter divided by tan theta. Theta is already given, means 6 divided by 10. What is theta? 45. You will get your answer of adjacent. You have two options. Either go with cos theta or go with tan theta. It's totally up to you.
Yes.
Yes.
Can we use Pythagoras theorem here?
You can use Pythagoras theorem here. Exactly. That would be the first choice here. Because you can see c square is equals to a square plus b square. C square is equals to a plus b square, and you can see the hypotenuse is given, means you can take the square of hypotenuse. So c is 8 is equals to a. You can say any side a or any side b. So you can say that a is unknown, for example, and plus b is 6 square. You can use Pythagoras here. That is applicable. So that's what I was telling you, that if you can use Pythagoras theorem, so that should be the first choice every time. Pythagoras is the first choice. Pythagoras is really easy. You just have to square the stuff. Trigonometry, when you are unable to solve with the Pythagoras theorem, then you have to go for the trigonometry. Or when you are unable to put the value according to the Pythagoras theorem, for example, you are unable to understand the rooting stuff or something, then you can go for the trigonometric ratios. Otherwise, the Pythagoras is always the first option because that is easier than the trigonometric ratios. Sometimes trigonometric ratios can be more difficult. For example, if I change the question like this, see, I'm removing the value of opposite now. Now you cannot use Pythagoras theorem. In first question, you had, you can say now, in first question, you had three options, the cos theta, the tan theta, and the Pythagoras. But now, I have removed the value of opposite. You have hypotenuse only. Now you cannot use Pythagoras theorem. You can use Pythagoras theorem when two sides are unknown, but both two sides, mean the opposite and the adjacent. These two sides should be same in length, same in size. Then you can use Pythagoras also. If adjacent is 6 centimeter, so opposite will be 6 centimeter. This is how we solve Pythagoras theorem sometimes. But if the sides are unequal, then in this case, which is on the screen now, you cannot use Pythagoras theorem because opposite is unknown. Adjacent is also unknown, and we have to find adjacent here. The hypotenuse is given only. Now, what will be your choice now? We have to find adjacent and the hypotenuse is given. So now the choice is only one, which is cos theta. Now you can use cos theta only. You cannot use Pythagoras now. So what you have to do, cos theta is equal to adjacent over hypotenuse. So hypotenuse is 8 centimeter. You can shift hypotenuse with the cos theta. You can find adjacent. Or in this case, if they ask you to find opposite also, you can find opposite also. Cos theta is equal to adjacent over hypotenuse. So with the help of cos theta, you can find the value of adjacent. For the opposite, you can go for sine theta, opposite over hypotenuse. Now, most of the students say, Miss, we are already finding the adjacent now. We are already finding adjacent with the formula of cos theta. So why we cannot use tan theta? Because we have already found the adjacent. So we can use tan theta to find opposite. There is a risk. For example, if you have calculated the value of adjacent, wrong. For example, you have calculated wrong value. You will get the wrong answer for the opposite also. That's why I am using some independent route. So I am using cos theta to find adjacent because hypotenuse is confirmed. That is given in the question. That is the right value. But I'm not using tan theta to find opposite in this case because I am calculating the value of adjacent, which could be wrong sometime. So just because of that risk, I would prefer using sine theta, opposite over hypotenuse, because hypotenuse is something confirmed which is given in the question. So I would use opposite over hypotenuse, which is the sine theta. Is it clear to you?
Yes.
Is there any question?
No.
Okay. Let me show you a question here. Let me pick some question from yes. Okay. Let's say this is a triangle. All right. This is a triangle, and yes, this is a right angle triangle. It means I can use Pythagoras or the trigonometric ratios both. Okay, so this is 61 degree. This angle is 61 degree. Definitely this is right angle triangle, so this is 90-degree angle. This is x centimeter, means we have to find this side, x centimeter. And this is 9.6. So you have to find the value of x. X is the side of a triangle. So this is the question. You have to find the value of x. So what you have to do first, you can see the opposite of the 90-degree angle is the hypotenuse. It means this 9.6 is the hypotenuse. Okay. Now we have to find x. So we have to check that what is x. X is, now we have to focus on 61 degree now, because we have already focused on 90-degree angle, and we have already checked that opposite to the 90-degree angle we have 9.6, which is the hypotenuse. Now let's focus on the other angle. The other angle is what is the other angle? 61 degree. So x is opposite to 60 degree. So 61 degree. X is opposite to 61 degree. So it means x is opposite. And this is adjacent, which is definitely not given. And we don't have to focus on the adjacent also, because they are not asking us to find adjacent. We have to find only opposite. X is opposite. So we can use opposite over hypotenuse. Opposite over hypotenuse. We have sine theta, we have cos theta, we have sine theta, we have cos theta, and we have tan theta. So you can check for sine theta, we have opposite over hypotenuse. So you can use sine theta here. Sine theta. Oh, wait. Yes, sine theta is equals to opposite over hypotenuse. All right. So sine theta, sine 61, because theta is given, which is 61. So sine 61 is equals to opposite. Opposite is not given, x divided by hypotenuse, which is given 9.6. So what you have to do, sine 61 multiply by 9.6 is equals to x. What is x? X is actually opposite. You can write opposite here. You can put everything into the calculator, and let me check what answer I am getting. Wait a little. It is giving me 8.40. You can round up the value to 1 or 2 decimal places. 8.4. centimeter. 8.4 centimeter is the value of x, means which is opposite. And now you have to check one more thing. Sorry, 8.4. 8.4. So 8.4 is the value of opposite. And I told you one thing, for the hypotenuse, we need to remember two things. Number one, hypotenuse is the side which is always present opposite to the 90-degree. And the other thing is hypotenuse is the longest side of the triangle. Now you can see the value of hypotenuse is 9.6 here. And the value of opposite is 8.4. It means the answer might be correct here. If I am getting the value of opposite greater than the hypotenuse, it means the answer is wrong, because hypotenuse should be greater all the time. This is how you have to solve trigonometric ratios. Let me give you one more example. Sometimes, yes. For example, yes. See, this is a triangle. This is a triangle. This is a side of a triangle, and this is another side of a triangle. Okay. So according to the question, this is 90-degree angle. According to the question, this is 90-degree angle. All right. So anything else? Yes, this is given. This is 41 degree. And this side is given 7.8. Now let me show you. They are asking you to find this side, x, and they're asking you to find this side, which is y. Okay, you can check if you can apply Pythagoras theorem. You cannot apply Pythagoras theorem here. You cannot apply Pythagoras theorem here. It means you have to go for trigonometric ratio. Okay, so let's calculate x first. It's up to you. You can calculate anything first. So let's check what is x. X is actually, this is the angle now. So opposite to the angle is 7.8. So this is opposite. This is opposite. So what is x? X is adjacent. This is a side which is connected to the angle. And what is y? Hypotenuse. It's totally up to you. You can calculate anything first, either adjacent or the hypotenuse, by using any trigonometric ratio. Let's say we are using a tan theta, for example. Tan theta, we just discussed. Wait, let me write it. Let me write the formula here. Tan theta is equals to, the formula of tan theta is opposite over adjacent. Adjacent. Yes. So opposite over adjacent. Opposite is given, adjacent is not given, and rest of the things are given. Okay. So tan theta. So tan 41. Adjacent. Adjacent is dividing there. You can shift adjacent here toward the left side. It will multiply. Adjacent is unknown. All right. That equals to opposite. Opposite is already given, which is 7.8. I just rearranged the formula. Actually, we have to make adjacent. We have to make adjacent. Wait a little. Give me a minute. Yes. Yes. So we have to make adjacent a subject. We have to make adjacent alone here. So adjacent is equals to 7.8 is as it is, which is opposite, and tan 41 means tan theta. That is multiplying with the adjacent. You can shift it toward the right side. It will multiply. So it will give you, wait, tan 41. You can put everything in the calculator. You can find the value of adjacent by 7.8 multiply tan 41. You will get 8.97 centimeter. If the lengths are given in centimeters, so you have to write centimeter here. If the lengths are length are given in meter, you have to write meter here. If the lengths are given in millimeter, you have to write millimeter here. There is no conversion. Okay, so this, what is adjacent? This is actually x. This is actually x. So you can write the value of adjacent here, which is 8.97. 8.97. All right. Now for the hypotenuse, you have two options. You have number of options for the hypotenuse. I mean, if we check the trigonometric ratios, so for the hypotenuse, we have, I mean, now we have opposite and adjacent both. So you can use, for the hypotenuse, you can use sine theta. Sine theta is equals to opposite over hypotenuse. You can calculate the value of hypotenuse by using this formula, or you can go for cos theta. Cos theta, because the formula of the cos theta is adjacent divided by hypotenuse. You can calculate hypotenuse from this because theta is given, which is 41 degree, opposite and the adjacent both are given in the question. But again, we have calculated adjacent and there could be the mistake in the value of adjacent. So instead of using cos, it will be more good if you use sine theta because the value of opposite is already given in the question. But again, you have two options, the sine theta or the cos theta. And the third option is Pythagoras. The third option is Pythagoras because you can see we are going to find hypotenuse. So you can see the opposite and the adjacent. These are two different sides. So one side could be A. You can take the square of this side. The other side could be B. You can take the square of this side, and then you can find the value of your hypotenuse. So you have three options now. So sometimes, I mean, in trigonometry, this will happen all the time that if they're asking you, I mean, if there are two things unknown in a question in a question of the right angle triangle, so if you're unable to use Pythagoras theorem, so the first option will be trigonometric ratios, but the other option will be Pythagoras all the time. Because now you can use Pythagoras so easily, and in Pythagoras there are less chances of mistake because in trigonometry we are using sine theta, cos theta, tan theta. There could be chance of mistake sometime. I mean, your calculator can give you answer in radians. Sometimes there is issue with the setting of the calculator. Instead of I mean, for the theta, for the angle, instead of degree, the angle is given in a radian. There could be a chance of mistake. So it's better to use Pythagoras theorem whenever you can do. This is all about the basic of trigonometry. Actually, you should have a strong grip on